Alright, so welcome back. Today we're going to talk about how to do derivations involving making assumptions and doing sub-derivations. Now, just like the rules that we learned yesterday, these reflect a natural way of reasoning. A lot of the time when you're thinking, you're going to have to ask, what if this or what if that, and reason through what the consequences of those what ifs would be. And these subderivation rules, these just reflect a way to do this systematically, to reason through these hypotheses in a systematic way. Now, when we do these subderivations, I want to emphasize again something that I talked about on the slides, which is that these subderivations are effectively a black box as far as the rest of the derivations is concerned. When you're in the box, you can see out of the box, but from outside of the box, you can't see back in. Relative to the rest of the proof, you only see what comes into the box and what comes out, okay? When you're inside, you can see what's going on in there, but once you step out of it, you can only see the output. You can't reach back into that box and pull out the contents of it to use again in your proof. It's part of the assumption, and that's where it stays. It's like a little scenario that you're building, but that scenario doesn't apply outside of itself. That may sound a little bit complicated. It should become more apparent as we go through these what it is that I'm talking about. So why don't we just go ahead and step into a few examples like this. So let's take a look at this first example here. We have as our premises, our assumptions. These are the premises of the argument that we're trying to evaluate for validity. If P, therefore Q, if that, then S. See, that's kind of a mouthful to say in English, which is why we have this language of sentinel logic to symbolize these sentences in the first place and make it more clear what's going on. If P, then R, if R, then Q, and we're trying to derive S from all of that to show that S is entailed by these sentences, meaning that an argument with these is the premises and this is the conclusion is a valid argument. All right, so it seems like we kind of have this chain of reasoning here from P to R and from R to Q. So it seems like we should be able to get if P then Q, which is the antecedent of this conditional that'll give us S. But in order to do that, we have to use a subderivation because we have to ask what if P, and we'll kind of reason out the consequences of assuming P. So on line 4, we're going to begin a subderivation with the assumption P, and our justification is AS for assumption, and we need to cite the rule that we're trying to use by making that assumption, because you just don't want to make assumptions randomly throughout your derivation. It wouldn't really make it wrong, but it would make it much longer than it has to be, and you'd have a lot of dead ends. So we should always try to keep in mind what rule it is that we're trying to use. And in this case, we're trying to get this. So the rule that we want to use here is the conditional introduction. Okay, from here, this proof is pretty simple. We get R by conditional elimination on lines 2 and 4. Now with R, we get Q with conditional elimination on lines 3 and 5. Now we can actually end our subderivation. And And we know that on the assumption of P, we're able to derive Q. So we can say if P, then Q. So we've made a successful conditional introduction, and we need to cite all of the lines of the subderivation. For these rules involving subderivations, when you come out and you have the output of the subderivation, you need to cite all the lines of the subderivation. Now, we could end this proof in one step, but I just want to talk for a second about the kinds of things you're not allowed to do here. Remember, this is effectively a black box now that we've stepped out of it. We've seen what comes in, and we've seen what comes out, and there's no going back in here. For example, we couldn't write Q here by reiteration from line 6. That's not okay. We can't reach back in the box to get Q. Likewise, we couldn't get Q, for example, by conditional elimination with lines 4 and 7. Line 4 is invisible to us now. You know, it went into the box and that's where it stays. But we can go ahead and finish this proof by conditional elimination on lines 1 and line 7.